Okay, next we are going to learn how to resolve forces along an inclined plane. So if let's say you had a block of wood, okay, on an inclined plane, what will be the forces acting on it? Now, for sure, there will be a weight, okay, so that is for sure, and for sure there will also be a normal reaction force, okay. But the third force, which is friction, would actually depend on whether the slope is frictionless, which is smooth, or whether it is rough. Now, if it has friction, the friction can actually act in either way, which means to say if the block was about to slide down, then the frictional force will be along the plane but upwards. But if the block is sliding upwards, that means you're pushing the block upwards, then the frictional force will be actually downwards. All right. So it depends on whether the block is sliding down or sliding up. If it slides down, then the frictional force will be upwards to oppose the motion. But if it slides up, then frictional force will be downwards to oppose the motion. Okay, let's consider a situation whereby you are actually exerting a force F to push this block of wood up the slope. So what will be the forces acting? The frictional force opposing your motion, the normal reaction, and the weight. So what we would do usually to solve questions involving an object on an inclined plane is to resolve all the forces in two directions, but we will not use horizontal and vertical directions as usual. What we will use instead will be parallel to the plane and perpendicular to the plane. That means we will actually resolve all the forces parallel to the plane and also perpendicular to the plane. Now, why do we want to choose these two directions, and are we allowed to do it? Yeah, we will be allowed to resolve in these two directions simply because the rule is any vector can be resolved into two mutually perpendicular components, and parallel to the plane and perpendicular to the plane, which is parallel to the plane and perpendicular to the plane, are perpendicular to each other. And the reason why we would prefer resolving in these two directions is because when the block slides down the plane or up the plane, we will need to find the net force in this direction. So if we were to resolve horizontally and vertically, we will not be able to find the forces in this direction. So which is why we would want to resolve in this direction. So how do we resolve this? The good news is the frictional force, the exerted force, and the normal reaction force, all these three forces are either parallel to the plane or perpendicular to the plane, so they do not have to be resolved. So that is another advantage. You only have to resolve your weight. So how do you resolve your weight? Now, if I were to draw this line, extend this line here, which is perpendicular to the plane, I will notice that the angle inside here will also be the same angle as the angle of the slope. So if this is theta, this will also be theta. So how do I get this? A little bit of trigo. This will be 90. So this small angle here will be 90 minus theta, because the total angle of a triangle must be 180 degrees. So 180 minus 90 minus theta, you will end up as 90 minus theta. And since this angle is also 90 degrees, so 90 minus 90 minus theta will also give you theta. So in future, you just have to remember this, that the angle of the slope, which is theta, will also be the angle between the weight and the line perpendicular to the plane. So this angle will always be equal to this angle. So when we want to resolve the weight, okay, so this is how we resolve it. We will select perpendicular to the plane, which is this way, and parallel to the plane, which is this way. All right, so let me just write the W here. So let's say this weight is here. So this component, which is opposite to the angle, will be sine. So therefore, this component will be W sine theta, right? So this component will be W sine theta. What about here? Now, since this component is sharing the angle with the vector, so this component will be cos, so this will be W cos theta. So always remember, okay, you can actually memorize this. First, the angle here will be equal to this angle. then the component of the weight which is parallel to the slope will always be W sine theta. The component of the weight which is perpendicular to the plane will always be W cos theta. So if this was in equilibrium, then the total resultant force in these two directions, which is parallel to the plane and perpendicular to the plane, will also be equals to 0. So we can write as 0 equals to, so what are the forces parallel to the plane? You have F upwards minus Fr downwards along the plane and minus W sine theta, because if you see, your W sine theta is downwards. So some people, some students, they have this problem identifying which direction are my components. So if this is my vector, if I move from here to here, it's basically saying that you're moving from here to here, then here to here. Right now, if you want to walk from here to here, you have to walk down and then walk to your left. So that is how you find your two components, right? So, and we are also taking the sign convention upwards along the plane as positive, which is why your F here, which is upwards along the plane, is positive, but these two are downwards along the plane, so it's negative. All right, now if you're doing perpendicular to the plane, same thing, your resultant force will be 0. And if we take upwards perpendicular to the plane as positive, then your normal reaction force will be positive because it's upwards, but your W cos theta is downwards, so it's minus W cos theta. All right, now if this question is for a system which is not in equilibrium, there's a net force, and the object is moving in this direction, all right, then in the direction perpendicular to the plane, the net force is still 0 because it's only moving this way and not this way. So this one will be the same, but if it's accelerating upwards, then your F will be bigger than your Fr and W sine theta. So your equation would be your net force will be equals to F minus Fr minus W sine theta, which you may equal to MA. Equate to MA if you need to find the acceleration. Okay, so this is how you solve questions on motion along an inclined plane.